All right, so permutations and combinations. You've done this before. Let's say you have a sandwich shop and you have two bread choices. Okay, yeah, you get the idea. Two bread choices, two meat, and two cheese, right? You can do that with a tree. Yeah? So you have, who did? And then you have a meat for each. And you have a cheese for each of those, right? So how many choices do we actually have?
Six.
Wrong. 8. Yeah. So you've used a tree diagram to figure out this is what we call the basic counting principle. It is the basic. You guys know how to do a tree. It's really easy, right? But what if you have like 50 items? Maybe. But what if I say you can only choose 10 of them? Okay, it gets more complicated, but it's, again, this is the basic part of it, right? You guys can do this. The question is, what happens when we have larger numbers, right? This is where we get into something called permutations and combinations. Permutation. An arrangement of objects in a certain order. If I flip a coin twice, I can have two different orders, right? I could have tails, heads, or heads, tails. Or tails, tails, or, okay. But if you notice, these are the same, right? They have the same coin face in them, tails and heads, but they're a different order. Okay. These count as two separate events in a permutation. But if we had a combination, which I'm going to tell you about next, that is the same thing. Okay. So in a permutation, order matters. That's the point, right? Order matters. This is the notation we're going to use. Okay, we have so many objects and we get to choose so many of them at a time. That's what we're looking at. Okay, so we would say it, the number it's a number of permutations of n objects taken r at a time. There's actually a cute little formula for it. Do you guys remember what factorial means? Like if I wrote, this is a side note, if I did this, four! Just a really excited four. I thought I'd shown you this before. It's called 4 factorial. Okay, that means right. It means a lot of multiplication. So if it's 10, right? If it's 10, 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2, bam, answer. 4 3 is 12. This is 24, right? There's a factorial button on your calculators. Do you want me to show it to you? All right, you better go get one. I did, didn't I? It's right there. Quit cursing in math class. Make sure I can find it. There it is. Okay, type the number in. Type 20. And then go to math. All the way to the right, it's PRB, and down to the exclamation number 4. Hit enter and then hit enter again. Right.
Holy bucket.
Holy buckets. Holy buckets drain water. Okay, so you know what factorial is now. The permutations formula involves factorials. So consider that formula when we talk about something here. You guys like to watch racing? Anybody like to watch racing? Horse racing, of course. Oh, I'm just kidding. NASCAR? Anybody?
I just know.
Track and field? Oh my gosh. Fast and the Furious. Okay, what are some of the characters in the Fast and the Furious? What are their actual character names? Dominic? That's right. Who else?
What's the name of the Hulk? That's what, who called it that? Terry Gibson called it that.
Who?
Yeah, the
Rock.
Rock. Name.
Hobbs?
He never said his first name, but
Who was Paul Walker? What was his name? Brian, that's right. Okay, so these three are going to race. The question is, how many different ways can they finish? Okay. Does order matter? Yes, order matters, obviously. So it's a permutation. Isn't he a cop?
Yep.
Yeah. Yeah, those movies just keep getting more and more ridiculous, but okay. If this order matters, it means we have to use a permutation. How many objects are there? And how many at a time are we taking? 3. Okay. So you're taking 3 people and seeing how many ways those 3 people can finish. We can also do 3 people and see how many ways the top 2 can be finished. Okay, that would be this. Right. The top one kind of throws us a wrench, though. What does the bottom become?
0.
Yeah, of our formula, right? Because it's n minus r. So in this one, the bottom becomes 0, so we're not even going to consider the bottom. Okay, so if they match, don't consider the denominator. And all you need to do is 3 factorial, which is 6. All right. I had something to say and I just forgot it. It's amazing. You could do a factor tree for the, or tree diagram for this too, right? If you have 1 person, then you have 2 possible seconds, or 3 firsts, so yeah, you could do a tree diagram for this. Let's just say that, if you wanted. What about the second one? How many ways can the top 2 be formed? We have to use that formula. Now it does turn out to be the same answer. But you see how that works? We're considering order. How many things can you put in place? That's permutations in a nutshell. Okay, the other one is what's called a combination. So we're looking at an arrangement of objects where order does not matter. Okay. Can you think of things where order really doesn't matter? Yeah, pretty much. What about books on a shelf? Does it matter what order they're in? In a library, it might. Yeah, so that might have to be a permutation, right? Let's think. You guys have any ideas? What? Yeah. Okay. Sandwiches. I'd prefer my meat outside my bread, personally. Apparently, that's the same as putting the meat inside the bread, right? If it's a combination, if it doesn't matter. It could be meat, bread, bread, or bread, meat, bread. It doesn't matter. It's the same thing. All goes to the same place. Okay. So I would consider sandwiches as a order does matter, but whatever floats your boat. No, it doesn't. Whatever order you get them in, you eat them, right? Okay. Combinations. There are fewer possible combinations That's the formula to figure out how many combinations of n objects take an r at a time. Don't. It's not that hard. You got a calculator there that'll do it in about 10 seconds. Yeah. The number of combinations will be smaller than the number of permutations. Okay. Like I said, head tails and tails heads is a different permutation, but in combinations, they're the same thing. Okay. So if you flip a coin twice, there are two permutations there, but this is only one combination because they're the same thing. Order does not matter, right? Same objects are there. Okay. The example in the book talks about paintings. Okay, so let's say you have 20 paintings. And you want to display four at a time. Does it matter which order you put them on the wall? Not really. People are still going to see all four of them, right? So what are the number of combinations of 20 objects taken four at a time? I'll just note that order is not important. And we plug and chug now. N factorial over n minus r factorial times r factorial. Do you agree? Disagree? Sometimes effort is not all that matters. Usually it's the user. That's what the book says. So if you didn't get it, we need to work on your calculator skills. If you type the top and the bottom separately and then divide those numbers, you can get it. Okay. The best way to do it is to put it in a fraction, but you have to put the entire denominator in parentheses in your calculator. So you actually have to do this. Oh, yeah. Predictable. So the difference, permutations, order is important, combination, it's not. Right? How many does anybody know how many candidates there are for, let's say, senior class officers? 2? Wow. 3. How many openings are there? Huh? I noticed. That's what gave me the idea to talk about it. Well, what if you had, say, 10 candidates and there were 5 open slots? Does order matter? If the 5 slots are all the same job, the order doesn't matter, right? But what if number 1 was the president, number 2 was the vice, 3 secretary, 4 representative? Does order matter then? So we would have to calculate a permutation, right? So you can calculate numbers of possibilities of that as well. There's an example in your book for it. But do you guys think you could handle that difference and using these formulas? Okay. Awesome. Tomorrow we will talk about something that should be a little more familiar. Probability and odds. $56.